Today's lesson is on inscribed angles, section 12.3. We're going to learn what an inscribed angle is and its relationship to its arc and how to find missing values. So we'll start with a couple of definitions. And we learned in the last lesson what an inscribed figure is. Inscribed means it's inside the circle. So an inscribed angle would also be inside the circle. The key to an inscribed angle is knowing that the vertex itself is on the circle. Okay, it's not just floating anywhere inside. The vertex is actually sitting on the circle. The intercepted arc would be the part of the arc, if you think about the angle as kind of a Pac-Man mouth, and if the Pac-Man chomped down right now, it would eat this part of the circle. The part that the angle would eat is called the intercepted arc. Okay, so the arc is the part in between the two sides of the angle, and the inscribed angle has a vertex on the circle. That's how that works. There's a relationship between those two pieces. It comes out as the inscribed angle theorem. It says that the measure of the angle is going to be exactly half of whatever its arc is. Okay, so if you find the intercepted arc value in degrees and divide that by 2, that gives you what your inscribed angle is. So for this example, if we took 68 and divided it by 2 and got 34, that would mean that our angle here is 34 degrees. And opposite, if I gave you the angle and asked you to find the arc, instead of dividing by 2 like we did here, if I gave you this one, if I gave you the angle, you'd take it times 2 to go back up to the arc. Okay, so you would divide to go down, and you would multiply to go back up. There's a couple of theorems and corollaries that go with this major piece of information, and this is really the focus of the lesson, is that the angle is exactly half of the arc. That is the key to today's lesson. The right angle theorem simply says that if your inscribed angle intercepts half of the circle, in other words, if there's a diameter there and the angle goes to the diameter, that the intercepted arc would be 180. So then when you divide that by 2, you'd be guaranteed a 90-degree angle. So that's guaranteed to be a 90-degree angle if it cuts the circle at the diameter. The third one that we're going to learn has to do with if you have a quadrilateral inscribed or a quadrilateral inside the circle, it says that the opposite angles, so the angles that sit across from each other, so those two would be opposite angles, and then those two would be opposite angles. It says opposite angles are supplementary. Okay, supplementary means that they equal 180 degrees if you add them together. So these two would add up to 180, and these two would add up to 180. The reason that is because opposite angles that are inscribed take up all the parts of the circle. Okay, so let me just switch colors here. And so for example, if I look at this angle, okay, this angle intercepts this much of the arc, right? All the way around here. Okay, whereas its opposite angle, the one that's over here, intercepts this part of the circle. So if you look between the blue angle and the green angle, the entire circle becomes an intercepted arc. And since the entire circle is 360, the two angles would be half of that, or 180. So that's why that is the case. Okay, to find the measures of those angles, let's start with the green one. This angle intercepts, like I said, this whole arc. So we'd add the 75 and 95 together because it intercepts the entire arc. And that would give us 170 degrees. And so if we divided that by 2, 170 divided by 2 is 85. Okay, so and you can see if I switch over to the blue angle intercepts these two arcs. If I add the 75 and 115 together, I get 190. And if I divide that by 2, I get 95. So you can see that 95 plus 85 is 180. Those two angles are going to be supplementary. Always. That will always be true. Okay? And same thing with the left and right ones. They will also always be supplementary. Let's try a couple of example problems. Things to remember that we've learned in past lessons. The arcs of a circle, even if a circle's cut up into arcs, those arcs will always add up to 360 degrees, because that's what a circle adds up to. That if you have a diameter, remember a diameter is a line that goes through the center, like this is a diameter. It does cut the circle into two half circles. So it cuts it into 180 degrees on each side. And then if you happen to form a triangle, that the sides of the angles of a triangle would add up to 180. So those are just things that we've learned in the past that might come in useful as you go through practice problems for this lesson. Okay, so let's start here. There's a couple of ways you could do this one. One is that if you notice, RT is a diameter. That means that it's going to be 180 degrees here, and it's going to be 180 degrees here. Okay, now we're trying to find this inscribed angle. So we know it will be half of this arc. It would be half of arc RS. Okay, now we don't know what arc RS is, but if we can figure that out, we would just divide it by 2 and that would give us our angle. Okay, so, but we do know that since RT is a diameter, that RST is 180 degrees. And if TS is 80, that leaves RS to be 100 because they have to be 180. So now we do know what that arc is. It's 100, so we would divide by 2, and this angle would be 50. Okay. Another way to look at this, if you wanted to look at it a different way, you can do that because I give you this arc, because TS is 80, then we would divide that by 2, and angle R would be 40. And we know that angle S here inscribes the diameter, or the 180 degrees. So we know that that's 90. So you could do 180 minus 90 and minus 40. That would also give you 50. So that's two different ways that you can solve that one. Okay. The second one that we're going to look at is we're going to go backwards. I give you an angle and I want you to find the arcs. Okay, we remember that the 3 arcs are going to add up to 360. I know this one's 137. If I can figure out what this one is, then I would subtract that from 360 and I would see what's left. Okay, I know that my angle's 53, so to go from my angle to the intercepted arc, I would multiply by 2, which gives me 106. So I know the arc from M to L is going to be 106. If I add 106 and 137 together, I get 243. So if I take 360 and I minus off the 243 that is already there, I'm left with 117, which means that this arc has to be 117 degrees. Okay. The last one we're going to look at is one of those quadrilateral ones. I'm looking for this angle. Okay. I know that it's supplementary to its opposite angle, so if I can find this angle, then I know 180 minus this angle is going to give me this one. Well, it just so happens that this angle intercepts an arc that I know. It intercepts 120 and 90, which if I add those together is 210. Okay, so this is an inscribed angle with a 210 degree arc. So if I divide that by 2, I get 105. And then my angle is opposite that, so it has to add up to 180. So if I do 180 minus 105, I get 75. So therefore that angle would be 75 degrees. That's the end of this lesson.